In this example, we're given an x and a y, and we're trying to be figuring out the partial derivatives in terms of x and y with respect to r. We can see that we've got separate equations here, but we're going to want to make one equation out of this. So it's kind of like r as a function of x and y. One way that we can do that is to say, you know how sine squared plus cosine squared is equal to 1. So we can rearrange this by dividing each side by this e term. And so we'll get that x e to the negative 2r is going to be equal to cosine. And then y e to the negative 3r is going to be equal to sine. And so if we square those, then we'll get x squared e to the negative 4r plus y squared e to the negative 6r equals 1. And then we can basically multiply both sides by e to the 4r. So that will get rid of the negative 4r's. It would be something like this, negative 2r there, and then e to the 4r. So now we have an equation that has an r on this side and then some x's and y's on that side. There is an r there, which we're going to have to deal with. But from here, we can basically do two things. We could take the dr over dx, or we could take a dr over dy. And when we do that, we'll end up with two different scenarios. On this side, we'll have a 2x, and then we still have to take like the derivative of this because there's r in there. It's just that we have to leave the y constant, so we'll leave that constant, and then we'll take the derivative of e to the negative 2r is going to be e negative 2r times the chain rule, so it's negative 2, and then it would be dr over dx. Okay, that's how we could represent that chain rule right there. And then we'll have that equal to, taking the dr over dx. This is essentially the same thing as e to the 4r, and then times 4, and then dr over dx. Okay. I'm going to take the derivative of y as well over here. I hope I can fit it in there. But essentially going to be 2y, and then we'll have to take the product rule here. So we'll leave that one constant, but we'll add the next version, which is the y squared. And then we're going to do e to the negative 2r, but then negative 2 dr over dy, just like we did over here. That's going to be equal to this side, exactly the same over there, but it'd be e to the 4r, and then 4, and then dy over, or sorry, dr over dy. So now we've got both x and y derivatives set up here. These are the partials. We just got to solve for dr over dx and dr over dy. It's not going to be too bad. Let's see. 2x plus, and then let's start manipulating these. So we'll have a minus 2 y squared e to the negative 2r dr over dx equals 4 e to the 4r dr over dx. Okay. Over here we could say this would be 2y e to the negative 2r minus 2y squared e to the negative 2r dr over dy equals 4 e to the 4r dr over dy. So let's put the dr's and the dx's on one side. We'll have 2x equals 4 e to the 4r dr over dx plus 2y squared e to the negative 2r dr over dx. And over here we'll do the same thing, so we'll say that 2y e to the negative 2r equals 4 e to the 4r dr over dy plus 2y squared e to the negative 2r dr over dy. Then we'll have to basically, we could divide out the 2's, and we could pull out the dr's. So we'll just say x is equal to, we'll put the dr over dx here, and then we'll go 2e to the 4r plus y squared e to the negative 2r. And then that's good. And then over here, it's just going to be, pull out another 2. So we'll have y e to the negative 2r equals we'll put the dr over dr of dy first, and we'll pull out the 2, so we'll have 2e to the 4r plus y squared e to the negative 2r. All right, we're close. I'm just going to divide this by the other side so that we get dr over dx is equal to x over 2e to the 4r plus y squared e to the negative 2r. Here we kind of get dr over dy is equal to y e to the negative 2r divided by 2e to the 4r plus y squared e to the negative 2r. And if we plug in the x's and y's with our original r's, so we don't want anything in terms of these x's or y's, we want everything in terms of r, so we just plug those back in. We'll say dr, if I can manage this, dr over dx is equal to, that was going to be a e to r cosine theta divided by 2e to the 4r plus y squared is just e to the 6r sine squared theta, and then another e to the negative 2r in there. And over here is dr over dy is, y was e to the 3r sine theta. We still have the e to the negative 2r, and we'll divide 2e to the 4r plus y squared is again going to be e to the 6r sine squared theta. And then there's still the e to the negative 2r in there. We can see that, like, this will simplify a little bit. So hopefully we can get this in the last line here. We'll have that dr over dx is equal to, let's see, if we pull out the 2 r's, this will become, first of all, 4r here. And we can also pull out the 2 r's. So I'll try to do that like this, because when we multiply that by that, we get a 4r right here. And then we could pull out the 2 r's. So we should get cosine theta divided by, I'll put e to the 2r here, and then there's going to be a 2 plus sine squared theta. That's going to be dr over dx. Okay, and then on this side, we can simplify this a little bit, but I'll turn this into just a one single r up there. And then over here, this will turn into 4r right here. And this will go away. And then we can kind of like pull out just one more r. And then on the bottom, it'll just be dr over dy is equal to just the sign on top. And then I'll pull out e to the 3rd r. And it'll be 2 plus sine squared, and that is dr over dy. Oh my god.